Hello Physics Nation, I'd like to do a second video on my practical analysis of a home gear system. On the last one I compared input motion to output motion. So if you do number of rotations on the input side divided by number of rotations on the output side, it's called the gear ratio. So this machine is a distance multiplier. A small input velocity becomes, as you can see, a huge output velocity. Except in this next video, I'd like to focus on torque. Torque is a twisting force. And, you can assume the tangential velocity is the same. That's what I did in the last video. But you can also assume the force that one tooth exerts on the other is the same. So these are just gears. And like I said, it's an action-reaction force pair. The forces that are applied to the input lever arm are the same force that is applied to the output lever arm. And the same force applied over a small distance will produce a smaller torque than the same force applied over a bigger lever arm, bigger distance. All right, so in the last video, I had a big input to a small output. That's a distance multiplier. That's a mechanical advantage, or excuse me, gear ratio less than 1. Now we have a tiny input to a big output. So that's a torque multiplier. And pardon my scrolling. Let's revisit what torque is. Force cross radius. We're going to divide both sides by radius to solve for force. And then we're simply going to set them equal to each other. So the input torque divided by the input radius is the output torque divided by the output radius. And then what am I doing here? Multiplying both sides by output radius and then dividing both sides by input torque. And now we're back to the definition of gear ratio, output torque divided by input torque. So again, if you have a bigger output than you have input, you're going to have a gear ratio greater than 1. That's a torque multiplier. Thanks for watching. See you in the next video.